All right, let's do this. Good morning, everyone, and thank you for joining us today for this really interesting webinar on the data scientist's job is more interesting with A/B testing platforms. This will be presented by Ronny Kohavi, Vice President and Technical Fellow, and Yuzheng, who's a staff data scientist at Statsig. I'm Sid from the product marketing team, and I just want to get a couple of quick housekeeping items out of the way as people trickle in before I hand it off to Ronny. The first is that we are recording this session. And so post-event, we'll be sending you the full recording with some resources so you can circulate these with your colleagues. The second is that we have a Slido link that Ronny dropped on the chat. Plus, there's a QR code that you can see on your screen. So if you haven't submitted questions already, please go ahead and vote for your favorite questions, because we've picked a few that were sent during registrations, but if time permits, we'll try to answer some more questions. So be sure to check out the Slido link and vote for your favorite questions. Other than that, I just wanted to give a quick plug for the sponsor for today's webinar, Statsig. Statsig is the complete platform for product growth that combines feature gates, experiments, and analytics to help you test in production, run hundreds of concurrent tests, and dive deeper into your metrics. I will share a few resources that you can check out. I'll drop them on the chat as Ronny gets started. So if for those who are interested, you can do some more digging on Statsig and also join our Slack community. We work with tons of awesome customers, some of the fastest growing companies of this generation. So if you're interested, you can get in touch with us via Slack or on our website. With that said and done, I want to hand it off to Ronny, who is our guest for today's webinar. This is going to be an awesome topic. We have more than 100 people in attendance, which is really cool to see. Wish there was a way on Zoom for us to share on webinars like how many people attend, but it's awesome to see more than 100 people joining us. So do drop a message on the chat to let us know where you're tuning in from. I know we have a pretty global audience today, so it'll be awesome to get things started by knowing where you're joining us from. And over to you, Ronny. Let's do this.
Thank you, and good morning or good afternoon, good evening, wherever you are. I see that we just passed the 100, so there's a Zoom limit that had to be dealt with, and I'm sure we got that right. I'm going to let Yuzheng actually take the first couple of slides to introduce the agenda and himself, and then I'll take over from there. Yuzheng, go for it.
Yeah, thank you, Ronny. And it's my pleasure and honor to invite Ronny to this webinar. Ronny is the expert in experimentation. I think everyone who came here should know Ronny already. So today's agenda is we are going to do a few brief introductions, and I will ask my questions. Ronny already spent time to prepare for the answers so we can learn from his deep insight and personal experiences on these questions. And then we have Slido. We already selected the top 5 questions from the audience, and there is also opportunity to vote the question. So when we have time towards the end, we can answer those questions as well. With that, a little bit about myself. Okay, who am I? I'm an experimentation evangelist at Statsig. My job title is a data scientist, but I'm enthusiastic about experimentation. I believe it's the best way to build conviction, understand the reality, and drive product with data. And that came from my previous experiences as a director of growth data science at Tencent, a data scientist at Meta, where I actually saw experimentation at scale and actually change product strategies. And before that, I was an economist at Amazon. I also do this YouTube channel called Pragmatic Data Scientist, where I interview experts from the field and just share insights and experiences of this craft. So I also got my PhD in economics from Cornell University, where I do a lot of causal inference models. And additionally, I also teach AI course on Maven, and I have a follower across different social media platforms where I talk about data science and career growth.
Okay, and let me tell you a few things about myself and my biases. I started in the field of getting a PhD in machine learning from Stanford. I was director of data mining and personalization at Amazon. One of my teams was WebLab, the experimentation system there. I then went to Microsoft, and for over 14 years, started and then led the experimentation team. It was a relatively large scale, even by today's standard. We had launched about 100 new treatments every workday towards the end of my tenure there, and that continued to scale afterwards. I then went to Airbnb, led relevance, personalization, and experimentation, and I co-authored the HIPAA book. You can see it's available, translated into multiple languages from Chinese, Japanese, Korean, Russian, and Polish. I'm now consulting, teaching, and of course, learning. I'm gonna hand it over to Yuzheng for the first question.
Nice, thank you. Yeah, so my first question is, we all read the HIPAA book, but it was published like 4 years ago, right? Or 4 years ago, and before the start of Statsig. So the kind of the landscape and the state of experimentation automation changed a lot since the publication of the book. But you are, following the industry and sharing your opinions, using the products and evangelizing the experimentation culture. So I want to kind of get your read on what is the current state of experimentation, especially experimentation automation. And the following question is, looking ahead, what are the unsolved questions or unsolved challenges for these platforms?
Excellent. So I'll start with the culture. I think there's much better recognition today that it's not just about the statistical formulas and doing a t-test correctly. There are lots of cultural challenges. I love this slide by Vineet. Everybody worries about the stats engine. Actually, a lot of the failures happen because of cultural issues. If the people at the top don't respect the data, if they don't want to make data-driven decisions, if they suffer from what's called Semmelweis reflex, which is this rejection of new knowledge because of some entrenched beliefs, I believe things are going to be tough. And I think there is today much better appreciation of that focus on making sure that people understand things like the hierarchy of evidence, being able to recognize that controlled experiments or A/B tests are at the top of that hierarchy, and multiple of them are meta-analyses or even higher. But that's a big, big change that has happened in the last few years. The second thing is we now have a much more realistic understanding that most experiments fail to improve the metrics that they were designed to improve. We've shared some statistics in the opening chapter of the book, but I think it has improved. We wrote a paper a couple of years ago called Intuition Busters, where we shared more of that and the problems that it causes. Here is this table showing you a company and then the estimated success rate. I worked at Microsoft in the early days. We estimated about a third. I think this is high because the initial experiments were sort of well thought out. We were very careful. They were based on studies. We didn't take a lot of chances with ideas because this was sort of the old Microsoft. Later on in my life, when I joined the Bing team and we set up experimentation there, our success rate we documented was about 15%, a lot lower than overall. And the reason is it's a mature domain, but also because we were launching a lot of ideas that did not have like research behind them. It was just trying things out, and many of them were breakthroughs. So I do think that's not necessarily a bad sign that you have a low success rate. It's actually a good sign that you're trying a lot of ideas because some of the breakthroughs come from that. Then there's a whole bunch of companies. Notice these are like the equivalent of full lines: Booking, Google Ads, Netflix, Optimizely, about 10% success rate. So if you look at the median of this table, that is this line. If you don't know anything, if you don't have any data, 10% is a good number. for estimating your success rate. And then at Airbnb Search, where I again worked, we saw a lower than 10%, an 8% success rate. And the reason, again, it's a mature domain, lots of machine learning algorithms were built to try and improve search. And we saw in the beginning that lots of our results were not replicating well, and that developed into this recognition that we have to lower the threshold for what we call statistically significant. I'll just share a funny Microsoft story. I came from Amazon, where we ran Web Lab and experiment. I saw the failure rate, and I came to Microsoft, and there was basically nothing going on in controlled experiments or A/B tests. And I told people, we got to build this because it's very humbling. More than half the ideas at Amazon failed to move the metrics they were designed to improve. And the answer was, we have better PMs here. So complete denial that this could be the case at Microsoft. Of course, you see the end result. It was definitely lower than 50%, and at Bing, it was even lower. So I think recognizing that it's okay or even recommended not to build a plan for, this is what we're going to do in the next 3 years, which was the classical Microsoft Windows and Office design, but rather design for multiple paths, evaluate them, learn to fail fast on some of them, learn to double down on the others as you build these MVPs and get the data about what's working.
Ronny, if I can just synthesize for the audience, because initially when I look at this slide, it feels like, most experimentations, quote unquote, fail. That is a bad thing. But then I realized actually it is a great thing for the product and for the data scientists, because that is reality. The reality is we are doing hard things, and ecosystem impact is very hard to predict. So you want to know which ones are winning and which ones are not winning. And I like your Microsoft story because, if you don't have this experimentation data to tell the PMs and the leaders what works, then you get into the hippo culture. You have people who have the best presentation, do their ideas, but data scientists basically do not have a say because people have this wishful thinking that prevails. Reality do not prevail. So by having experimentation, by telling people what actually works, what doesn't work, that's the foundation of the truthful, I guess, iteration based on reality and the true data-driven culture.
Exactly. Great point. I also take this opportunity to drop a LinkedIn post in the chat where somebody wrote, and I quote, the 92% A/B test failures at Airbnb, the company should work to figure out what is wrong. It said 92% of its bets are failing. And I wrote a response and explained why this is. And so you're welcome to look at, I think it's a good thing. Like Yuzheng said, recognize the reality, recognize that you shouldn't develop some of these things that are failing. You shouldn't even put them in the product because they're useless. You're just complicating the code base. You're just adding baggage and maintenance for the future if the feature has no value and yet you launch it. Okay, the third slide here on recent developments, I think, is there's recognition now that trust is a key aspect. We put this trust in the sort of the title of the book, and this is one of the things that I was very proud of at Microsoft. And I will say outright, I think the system at Amazon did not focus enough on trust, and we had issues over time. But I'll mention a couple of things that I think are critical and recognized today, starting with SRM. Back in 2009, we wrote this paper called 7 Pitfalls, and we suggested to do this critical sanity check and verify that users are divided between the variants in the appropriate ratio. 6 years later at CXL, I actually gave it the term SRM, which was the term that we called at Microsoft just to make it easy. And that caught on. A lot of people are now using that name. And this is from the summary of the talk that was put out there. So I think today it is actually rare to see an experimentation platform that does not do SRM checks. Lucas created this link, and we'll give you the slides. You can click on these for the list of platforms that do and do not support, or I think it's only the do that support SRM checks natively. I wrote this post that, you know, a platform without SRM checks is like riding a car without seatbelts. We all recognize today how important it is. And I'll mention AA, I didn't go into details, but this has been one of the most useful tools for us to find out bugs in the platform, bugs in our variance computation, bug in specific metrics where the variance needs to be computed using the delta method or other things in the default is not valid. So I think that's a pretty important recognition that has increased in value in the last several years. And then we used to say, you know, no peaking. You know, there was this like early phase where companies built software that peaked, and, you know, I'll ding on Optimizely here. Their initial version encouraged people to peak, and it was wrong. They were statistically naive, and then they, of course, fixed it. But lots of posts in those days saying, hey, no peaking, no peaking. It is okay to peak if you plan for it. This is called interim analysis. We now have much better understanding, and products have started to build these things where we allocate some of the alpha into early tests to see, especially on the negative tail, that we're not hurting users. So we want to be able to launch new code quickly. We want to experiment and not put too much QA effort in the beginning. But if we launch something that's bad, you know, it just tanked revenue by 10%. We want to be able to abort quickly. And this is where I find interim analysis is highly beneficial. And there's good science behind it. We got to learn from the statistician that did this. This is way back in the 70s and 80s that all this, you know, technology was built. Cupid is something that we introduced at Microsoft and is now being implemented by a lot of companies, including the sponsor of this, Statsig. The basic idea in Cupid is a variance reduction. So instead of seeing your two distributions like this with some delta, this is H0 in blue and H1, the alternative in orange, you can actually lower the variance, and therefore the normal distribution gets squeezed, and this critical value, which anything to the right is Statsig, moves left. That's a huge benefit, gives a lot of advantages when you can detect smaller changes with lower p-values. And then the last thing that I think is now gaining a lot of recognition is HTE, or heterogeneous treatment effects. Statsig calls it differential impact detection. I called it segments of interest in the book, but I think this is one of those things that when implemented properly has amazing insights. And I think these are now being more and more introduced into products.
Cool. Ronny, if I can
Yeah.
resonate and provide some evidence for this slide. The development, I definitely see that like over the past few years. For example, at the beginning, I think people are naive, and then a lot of things are automated. But then behind that, I think there is also up-leveling of engineering. For example, people didn't like SRM because, you know, it creates, you need to rerun the experiments when you discover SRM. But the engineering integration made it easy to detect, fix, and prevent it even. So it's more acceptable. And with more like necessary checks going into these platforms, now we are seeing kind of checks around business decisions. For example, if you have a different baseline before experiments, statistically it's not wrong, but in terms of business, you probably need to rerun the experiment, and then people start to monitor that and try to, you know, flag that at the beginning of the experiments. So I do see this, you know, the development of the platform that makes experiments more automated and more likely to not result in any, you know, system error.
Excellent. Okay. You asked about key challenges that I still see today. I think the modeling of the long-term outcome, you know, if you think about this idea of an OEC, the overall evaluation criterion, it's supposed to be reflective of long-term things like customer lifetime value, business value, modeling that so you can actually have metrics evaluated in a couple of weeks in an experiment is a hard problem. And there are newer papers that came out, like the ATHI paper on surrogates. But I think it continues to remain a highly, highly challenging problem that needs to be addressed. There are interactions and violations of SUTVA, the stable unit treatment value assumption. There are more and more papers coming out to address that. I think we're making progress, but I think I still see that as an interesting challenge. I'll end with something that is, I think, evolving very, very recently is the use of LLMs. One of the greatest uses is idea generation. Can I generate more hypotheses to test? Interesting paper that appeared last year from Wharton. They claim that LLMs they were using are able to generate faster, cheaper, and most importantly, higher qualities ideas. As far as creativity, a lot of people ding LLMs. They can be creative. They just parrot things out. Well, here's a paper that claims that there's definitely the potential for creativity. Last week, there was a workshop at EXL in Austin, and they did a beautiful presentation and a workshop where we took customer feedback. So, you get a spreadsheet with hundreds of responses from customers. You feed it the ChatGPT or Perplexity. It lets you summarize the issues, and then it generates root causes. And then it generates proposals for hypotheses to evaluate an A/B test. So really cradle to grave, end-to-end opportunity to use LLMs to improve the overall A/B testing in your company. So I love that. I think it has potential to make some fundamental changes in the way that companies run. And, I see in the chat, people are saying, can we get the reference links? Yes, we will hand out the deck at the end. And so you'll be able to click on all these blue links.
Yeah, just a quick follow-up question. Like, I think the LLM is about generating hypotheses. But do you see it's possible to kind of understand the result of experiments and provide reports and try to,
I mean, these are open directions. I haven't, I'm hopeful that, for example, it will be able to find and explain segments of interest. I haven't seen that yet. I'm more cautious. Lots of shiny new objects to show up in the world. Most of them fail. This one, I think, is at the point where there is good evidence that this could make a fundamental change. So that's why I'm mentioning that.
Cool.
You got the mic.
Yeah, so the second question is, okay, there are a lot of automation going on and seems to be more and more sophisticated, seems to, quote unquote, replace a lot of previously maintained jobs of data scientists. Then what does this mean for data scientists? Which part of the job are likely to be automated if you are not using one of the platforms? Like, it's gonna happen no matter what? And like, just what does it mean?
Yeah, great question. So, I worked at Microsoft and Airbnb, and I think the Microsoft team had a very large experimentation platform. The engineering team was about 70 people at the end, so lots of investment. And the goal for the engineering team was actually to, like we joked, put the data scientists out of a job or make it more interesting for them by removing any redundant activity that they have to do. So we managed to go high scale, very much in favor of fewer errors, complete automation. And the data scientists basically had to deal with unique problems, right? It was as much automation as we can get out of the system. At Airbnb, I would say it was the opposite. I joined, there was a very small experimentation platform engineering team. And because of that, every experiment required an analyst, it was delays, there's lots of errors. It was just really, really hard to scale. So I believe that the fact that now third-party software vendors are providing a lot of that automation is actually going to allow companies to scale a lot better. It is critical and important to automate as much as you can and then leave the one-offs to the data scientists. They get a more interesting job to do, and yet we can scale experimentation. And that includes like all the trust checks. It shouldn't be that the data scientist does SRM checks or runs AA tests or looks for guardrail violations. The system should do it. I think as far as insights go, The data scientist shouldn't slice and dice the data to find interesting segments. The system should try to do that. That is a much harder thing to do engineering-wise, but that's how you scale.
Oh, I also want to kind of
Yeah, go for it.
my resonance of this one. I think at Meta has the, I guess, most automation of data scientist jobs that I have experienced, or I compare those with other companies. Meta has the most automation of DS jobs, but Meta probably has one of the highest data scientist to engineering ratio. At Meta, it was one data scientist to probably 6 to 8 engineers, which I think comes from the second order effect of automating the job. It's not only, like there were 10 jobs, now data scientists focus on the one off, but also the secondary effect is people are much more data driven and data has much more of a say. Data scientists have a seat on the table and they get to do analysis, influence decisions. They become more important within a company and they just get more job as a result.
Great. Okay, question 3 for you.
Yes, this question is kind of similar to the second, or is an expansion of the second question. That is, once the mundane task of experimentation are automated, what shall we do instead? Because many people, if they are heads down with the mundane task, they don't see what are the possibilities. So from your perspective, kind of enumerate for us what are the things we can do.
Okay, so I'll make this a little shorter. I think one of the more interesting tasks for data scientists is to translate the results, the numbers, the statistics into a story that people can grok and can resonate. For example, when we did our performance test at Bing to see how much speed is important for the website, this is the story that I wrote. An engineer that improves server performance by 10 milliseconds, 1/30 at the speed that your eyes blink, more than pays for his or her fully loaded annual costs. Every millisecond counts. When somebody comes to you with a A/B test result that seems to be doing better and they want to ship it, but you notice a 50 millisecond degradation, you're going to tell them, are you willing to give up 5 heads for this? Because that's the cost that you're introducing. Okay. Second problem is defining the OEC, the overall evaluation criterion. I mentioned this before. One of the hardest problems is identifying these driver metric or surrogate metrics that are causally predictive of the long-term outcome that you want. Defining guardrails in general, defining the right debugging metrics so that when something comes out and you get a scorecard, you'll be able to generate that insight of not just what happened, but why. Trust metrics, click fidelity. I've not seen a system that has 100% fidelity on clicks. We all have some ways to lose them. There's a trade-off between the reliability of the click and the delay that it introduces. Things having to do with cookie loss. Cookies are lost regularly. And being able to build some of those metrics to alert you that, hey, for some reason, looks like click fidelity went up or down in this experiment. Stop. There's an issue. That's important. And then finally, the ability to call Twyman's law, right? Which is, hey, these results, they look too good to be true. Nothing moves an OEC by 20%. So if you see that, stop celebrating, look for the bug. Now, it could be that this is real. It is very, very highly unlikely. Okay, last question.
Yeah, the last question is, everything above sounds very nice, but then how can we get leadership to buy in? How can we get leadership to support data scientists and support automating experimentation?
Yeah, so to me, it's about the ROI. It's very clear to make the case that this is the most trustworthy, the gold standard in science method to evaluate changes. And if we're able to move to a world where everything is A/B tested, every change, every tweak is actually checked, then we protect ourselves from the bad things and we're able to discover the good things. So you can make the case that with a good platform, the analysts will grow sublinearly. You don't need enough more analysts. We had this idea of a center of excellence. We help teams onboard with 1 or 2 analysts from our team, and then they have to scale on their own. They have to hire their own data scientists. We did not increase resources as they start to scale the number of experiments that ran. And that, for me, seems to have worked very well. We are going to go, we're right at time, so 10:30, and we're going to go into the audience questions that were given on Slido. I picked the first top 5, but I do want to add a quick note for those that want to learn more. I teach 2 online courses on Maven. The first one is called Accelerating Innovation with A/B Testing. 5 sessions, 2 hours each, starts December 2nd. And if you are going to click on this link, you are going to get $250 off. Let me put that in the chat for those that want to look at that. There we go. And then the second course is a new course on advanced topics in practical A/B testing. That's a class that is just 2 days of 2 hours each. And there is the link to that one. So quick interruption, but let's go to the Slido questions. We all gave you this link. You're welcome to look at it again. And if we have time, we might go a little bit more. But I did 2 things. One is, first of all, I gave these questions to the experiment ChatGPT. So this is a GPT I created that has the book that I co-authored and some of the lessons in my class. And it's doing a pretty reasonable job at answering some of the questions. So you're welcome to look at that ChatGPT to see how well it does. I'll put, again, the link to that in the chat. And for this session, for the actual answers that I did, there's a link if you're interested that allows you to see the answers to the top questions that you have out there in the Slido. So that's the log of that session. Okay, so since this was Slido, I'm going to read this and I'll let Yuzheng chime in when he wants. Question 1, how do you get started in A/B testing in an organization that does not do any A/B testing? The wording is verbatim. I slightly rephrased this. So here's my suggestion for you. 1, pick a beachhead. It's a military term, but basically an organization that can start to do A/B test in the wider org. Don't try to deploy it in 15 different groups. Pick a group, a sub-organization that meets certain criteria. 1, they're interested in running A/B tests, and they're willing to be humbled. That's important. Okay, 2, they're agile. They have to ship often because you want that feedback cycle to work. If there's a team that ships every 6 months or every year, not a good candidate for A/B testing. It needs enough traffic. My default 200,000 users is where the magic happens. There's a link here to a talk where I explain why. For most sites, this is a good start-off point. Now, you may need less, you may need more. Obviously, you have to plug it into the power calculator, but this is sort of a rule of thumb number. If you're way under, if you've got 10,000, you're not ready for A/B testing yet. Can we agree on an OEC? Can this group have some metric that they agree as an org they're going to optimize long-term, and can we build some short-term metrics to evaluate it? That's a hard problem. A good example that I had is Microsoft.com. It is a site that does 7 things. It tries to help you, it tries to sell you, the group doesn't have a good sense for what they're really optimizing for because everybody's vouching for their own piece of what the site is doing. So it's a tough, not an ideal site to do A/B testing on. And then they're already logging some things. If you have to start logging user activities, then it takes a long time to get started. So the better they have as far as logging the views, the clicks, the performance, the user hovers, all that, these are all things that help you find an organization that is going to be great at A/B testing and will see the value. So you pick a beachhead. The second thing is you need some expert. You need at least one person that really understands A/B testing so they can guide the organization, point out flaws, help people understand why this whole thing is at the top of the evidence of hierarchy. And then you have to either build or buy. I think these days, there's a lot of opportunity to look at platforms. I'm not going to say that Statsig is the best, even though they're sponsoring it, but they are a great experimentation platform. I ran 8 sessions of 1 hour each in my class, and there's a link here to those decks. So I invited vendors to present their platforms. You can see every vendor answering 5 questions that I asked. Statsig is in there. I invited agencies that work with platforms to comment on why they prefer one platform over the others. So lots of good information here, lots of decks that you can look at to see and help you choose the right platform.
Ronny, I
Yeah.
want to provide a prescribed opinion on this getting started question, and also relate to one of the Q&A question of telling the story. Do it become subjective when you tell the story? Kind of like when you answered, one of the job, the better job for data scientists to do is to tell the story. Most data scientists would actually feel like, okay, my job is to provide the objective truth. My job is to just present the number. But I agree with you, and I believe our impact comes from how much we effectively influence other people, how much we change the decision for the better, and how much we drive actions. Because our job is useless unless we can convince someone to do something if we are not writing production model. And this is part of that art. Like you need to have the influence. You need to tell the story. It's not being subjective,
Absolutely.
It's just being effective.
Absolutely. Okay, question 2. What are the bigger pitfalls to avoid when building or scaling an experimentation platforms? So the first one is high expectations. Remember, show them this table that I showed earlier. Most experiments fail to improve the metrics they were designed to improve. If you come in with that expectation that you're going to have 80, 90% failure rate on your experiment, but it's an opportunity to learn. This key doesn't open the door. This key doesn't open the door. Let me pivot. Let me fail fast. I'll find something else that opens the door and is positive. And as you get more experiments, you'll find the things that work and you'll be surprised. I think insufficient investment in the trust aspect and in the guardrails, right? This is a poster that we did at Microsoft. Trust me, IVXP. That's the name of the platform. We said this, getting numbers is easy. There's a lot of platforms out there that give you numbers, but getting numbers you can trust is hard. You have to invest in that. So as I mentioned before, you got to test for sample ratio mismatches. You got to run AA tests. You got to validate the data that's being logged. How high is the fidelity of your instrumentation platform? You should implement auto abort. If something bad is launching, abort it early. Don't let users suffer. Okay. Third pitfall is just lack of agreement on the OEC, that overall evaluation criterion, which I think emphasized is a big problem. This one is another one that a lot of people miss. Statistical power. There's a formula. It's simple. You plug in the data for your metric based on last week's data. You can get the variance. You plug in your MDE, what the detection minimum detectable effect that you want to have, and it tells you you're going to need 200,000 users. Now, the problem is people say, I don't have 200,000. I'll run it with 50. Maybe I'll get lucky. No, that's wrong, because you're going to suffer from something called the winner's curse. All your results are going to be exaggerated if they're statistically significant. You got to be really careful to make sure that you have enough power. There are papers with pitfalls at this website that when we build EXP, we set up. So you're welcome to look at those. And then also remember, ChatGPT, I gave it this question, has a lot of good points in addition to the ones I mentioned. Yuzheng, any comments on this?
Yes, I want to provide, like, A/B testing is one of the easiest thing to start. You can have Excel and do A/B testing, but one of the hardest thing to scale, because the information overhead and managerial overhead just increase super linearly. And a lot of data scientists make the mistake of let's be very rigorous, but exclude other product development members in this, which also makes it even harder. So I actually have an entire deck on scalable experimentation, how to design the system well, how to integrate with feature flags, how to do data quality to make your experimentation program scale, whether you buy or build. I think those technical insights are useful, and we'll share that at the follow-up email.
Great. Okay, question 3, the center of excellence. If you are a center of excellence in a decentralized organization, that is, you don't own running experiments, what is the difference in driving experiments versus centralized team? So first of all, I want to give you a pointer. It's a Harvard Business Review article that talks about the 3 models of centralized, decentralized, and the center of excellence. The centralized team will have A/B testing expertise, but in a center of excellence, you help the other team to onboard, but they must build the expertise. Okay, so that's sort of, they're coming in from the business side, and the advantage is that the centralized team has to grow as experimentation scale, but in a center of excellence, you don't grow that team linearly with the number of experiments. You push the resources they need to the team, to the distributed teams, and let them scale. And that has huge benefits because they're the experts in their domains. They know more, right? So you have A/B testing knowledge, but a lot less business knowledge. In the center of excellence, the business team have the business knowledge, and they learn the A/B knowledge. Working together, that trade-off is such that as they scale, it's easier for them to learn the A/B testing than it is for you to understand their business. So I'm a big fan of the center of excellence model. Help them ramp up, help them get started, but over time, they have to scale themselves. Okay, there are other factors that differentiate between these 3 models. Who does the education? Initially, the centralized or the center of excellence team has to do this. There are questions about career growth. If you're specializing in A/B testing, then clearly you prefer the center of excellence or the centralized team. And then who builds this critical institutional memory to remember some of the insights that you've had? I don't know, Yuzheng, if you want to have any comments?
Oh, no. Yeah.
Okay, cool. Question 4, what do you do with flat results? These are actually 2 questions that were voted high that were very similar. How do you explain when the p-value is valid and people have a bias towards declaring success? And then another question was, if you have neutral or negative, but not statistically significant, is it bad to ramp them up? So I'm pretty clear here that, if your p-value is valid, the experiment is correct, but it is high, meaning you cannot reject the null hypothesis, you cannot say I'm doing better, then, you should conclude that the experiment does not have a material impact on the metrics that you care about. It may not be 0, but it's small enough to be consistent with the null hypothesis. It's a good opportunity to learn, but you have to be realistic and decide if you're going to iterate one more time, or you pivot and fail fast in this direction. I believe that shipping flat features, those that are not Statsig, is a bad thing in general. There are obviously exceptions. It complicates the code base. You're just added things for team morale effectively. It's not helping your metrics. And there are costs to pay for that. Okay. Now, it is sometimes important to ship something that's flat. For example, if you're refactoring code, then you want to say, my goal is not to improve the user metrics, but rather to improve my ability to build new code in the future, right? So your goal is non-inferiority here. That's okay. Sometimes there are legal reasons. FTC comes along and tells you you have to do X or Y. Then, of course, you want to be able to try and go for flat, which is considered to be a good thing. And then there's some strategic reasons where you're building critical infrastructure that you think will be useful in the future. This is more debatable because I've seen people, a lot of people ship because it's strategic, but then, 2 years go by and there was nothing that was positive in all this strategic area. There's a post here that I discussed this in more detail, so you're welcome to look at this and the caveats and everything else around it, and there's an opportunity to comment on it. This is it. We are right on time at 45 past the hour. I'll switch it over to you, Chang, and you can decide if you want to do one more or whatever.
Let me ask one slide of questions because it's
Yeah.
voted as the other top 5. What's your opinion on having a universal holdout to evaluate the impact of all initiatives over some time and the recommendations for the best practices?
Yeah, so when you say universal holdout, let me define 2 possible interpretations of that. One is I'm running a holdout for users that are not in any experiment. And my goal is not to evaluate the value of experiments, but rather to evaluate the experimentation platform itself, how much it is slowing you down, how are we doing against that. I'm a fan of that one. But this just says you're not in any experiment. We keep you for a while just to measure the impact of the experimentation platform itself. This is easy to implement. And then there's the other approach of saying, let's hold back 6 users for 6 months from any features we're launching so that we can estimate the cumulative impact of those features. It sounds wonderful in theory. I've seen it fail over and over again because it is expensive, super expensive to implement. Think about all the refactoring that happens to make code easy. Now the engineers have to work hard to also implement this in the old version. They can't take advantage of the refactor. Think about outages or issues. If they happen on your 90% base, everybody wakes up in the middle of the night, they're motivated to fix it. If it happens on the 10% that's in the holdback, well, it's degraded by 2% on the 10% holdout. We can wait until tomorrow. And so effectively what you're doing in many cases is you're crippling the holdout group. There's a famous story that I share about how we did this for Bing, and it turned out that, some pipeline that was feeding into the old code base, its format changed and it just degraded. So effectively, it looked like we were doing really well with our treatment continually beating the control, but it was we crippled the control. So I'm not a fan of that. It's one of the topics that I speak about in my advanced course, and I give examples, but just that you understand it sounds wonderful. We've tried it several times. Every time it failed to deliver on the promise. So I'm now more realistic, saying there's a huge cost to that. Make sure that you're willing to pay for it. And talking about cost, think about this. If you're holding users 6 months back and you've done experiments that add up to 10% improvement on your revenue, you are losing 5% of revenue that half year. That's a lot of money. Are you willing to pay millions of dollars in a large organization just to get that number? Okay, thank you.
Thank you. I think we are out of time. So thank you, Ronny, for everything. And not only today's webinar, but also, educating, writing the book, and all your LinkedIn posts. So if you are not following Ronny, highly recommend. And we will share the recording. We'll share an edited recording plus my interpretations on pragmatic data scientists. So please check out and subscribe to that channel. And we'll link all the resources. For example, the scalable experimentation in a follow-up email. You should have everything.
Thank you, everyone.